Hello everyone and welcome back to another Oats video. Last time we started building our web app and we were able to create two fragments, one for a HTTP cuts and another one for movies fragment. So I'll just run the project so that we can refresh ourselves. What we're able to achieve so far. Now in this lesson, we are going to add reactivity and data management. And just like before, I'd written about this the previous article. I've written this in an article. I'll link that article in the description. And the source code is also available on GitHub. I'll also provide a link in the description. So you can just clone, install the dependencies, just npm install and then just run. And it should be fine. And you can follow along. And if you are coding along with me from the last tutorial, you can just carry on from there. Now, previous tutorial, we had this view, whether HTTP cards and movies, the two fragments, and you could be able to navigate between them. We're able to hook up our routing information, provide the views for this fragment, and now we are going to actually use the APIs available to make this button and this search right here functional, so that you can actually be able to retrieve data from a server and show that data in our front end using Oats. Now, for the APIs that we'll be using, there's one where we need to have an API key, and this will be for the movies fragment. Getting that API key is not difficult. I've linked to the page where you can sign up. That website is themoviedb.org. You can use this address. I'll have pasted it in the description as well. And if you want to know how to generate your API key, there's this YouTube video. It's just 5 minutes long. It won't. It's quick and easy. And once you have your API key, of which mostly prefer to use the session key because the API key doesn't work quite well. So I prefer to use the session key. You grab the session key and then I'll show you how you'll be able to use it. You'll be able to use the movies API that we'll be using in this tutorial. Now, let's get right into it. The first thing that we're going to do when you're adding reactivity to a web app is that we'll start with the cuts main fragment, this one right here. Our objective is to click on meow and have a new cut image loaded here using the HTTP cuts API. Now, the first thing that we'll do when you're adding reactivity in Oats is we use a class called the data manager. The data manager allows us to define our models, have the data manager as the only source of truth, where we're able to handle our mutations. And then as far as the view responding to these data mutations is concerned, we use the view manager. And just look at the article that we had previously, the first article that we had in introducing Oats. There was a nice diagram that explained this. This one right here. You see our data manager, which is the source of truth as far as the data is concerned. And then you have our view manager, which responds to mutations being handled by the data manager, and that is what shows the reactivity as far as the web app is concerned. And then you have a network interface which the data manager uses to communicate to the server to get data. Now, we're going to do this practically. What we'll start with is first defining our data model, and you just define it using JS docs. You can also use a TypeScript declaration file to do this, but for simplicity and for this tutorial, we'll just use a JS doc template. So we'll go to our HTTP cats main fragment, which is inside the scripts folder for HTTP cats. And then now at the top, where we define our class, we just define a JS doc type. And this type will be the HTTP cats model. It should have one property and of the key IMG image of a value string or of a type string. So we'll do that. So if I hover here, you can see HTTP cats model is actually an object, and it has the key IMG image that takes data of the value string or of the type string, data of the type string. Now, once we have this, we can finally set up our data manager, and then using JS docs, have it understand the type of data that it will hold, and this will make using the data manager much easier for your case. So we'll set up our data manager in the constructor, and the reason why it's good to do this is that it allows for your fragments or even view panels to already have the data manager set up before the actual rendering starts. So you can actually start using the data manager in whatever steps of the rendering process that you need. So we'll set up our constructor right here. And in Oats, the fragment constructor takes a single argument, but it's an object. And then what we'll do is we'll call super. This is a child class. Once you've done that, we'll now write this code right here. So the first one, I'll copy the first bit of code, explain what that is. So is our first bit of code. So this is just a random, it's an array holding a list of HTTP codes. And these are the HTTP codes that you pass to our HTTP cats API. And given a specific code, it will return a specific image or a unique cat image. Now, how we use this is that once you have this array, we'll be generating an index that is within bounds, a random index that is within bounds, and that will randomly get us a code, and that code will now give us the right image for that code. So that's how we randomly get a cat image when you click on view. Now, with this setup, now we're going to look to get into the data manager, and we're going to set a data manager instance. And to do that, assign it to the instance variable, this HTTP cats data manager, and this will be an instance of the data manager, new data manager. And when you create an instance of the data manager, there's some constructor arguments that you pass to it. The first one is the primary lifecycle object, and we get this by calling the inner method of our fragment, or this get lifecycle object. Now, the reason why the data manager needs to have an instance of the lifecycle object is that it handles lifecycle management automatically for you. So in case there are any data mutations that are taking place, and then this fragment, the HTTP cats main fragment, was destroyed because the user routed, let's say now to the movies fragment, any operation that the data manager was handling will be automatically cleaned up, so you don't have to encounter any errors. And any broadcasts that are being made to the view managers, which were dynamically rendering views within this fragment, will also be stopped. So as far as the data manager is concerned, you don't have to worry about lifecycle management. Passing this object right here gives data manager now the capability to do that. The next thing we pass is the master API options. And for this, we pass in an object, and then there we pass the request utils. And for that, we pass in an instance of the lifecycle remote request utils. And this one takes the constructor, takes a lifecycle instance as an argument. Now, the master API options basically allows you to provide to the data manager the request utility, remote request utility that it will use to make remote requests through the network interface. Now, this is an inbuilt class that comes with Oats, and from the name, you can tell that the network calls that you make in Oats using the lifecycle remote request utils class are also automatically lifecycle managed. So if you're making any network request in your fragment, you're using this utility, the fragment gets destroyed, this utility will automatically note that, and it will stop the requests, clean up, and you don't have to worry about any late callbacks or resolution of your promises. Now, with that set up, the last thing to do is to now annotate this with JS docs so that you get the right type preferences whenever you're using HTTP CATS data manager instance. So to do that, we just use JS docs. And we just specify that type is data manager HTTP CATS model. And that's it. Now, the next thing that we'll do is that we're going to set up a function called setup data manager, where we'll now set up the network interface that the data manager will use in conjunction with the request utility to make network calls as far as data mutations are concerned. So I'm going to call this setup data manager. And then right outside the constructor, you're going to implement that method. And then we'll come back to these later. For now, let's go to the setup data manager method. Now, in this method, what you're going to do is we're going to set the network interface that is going to work with the request utility to make the actual network calls. Now, to do this, we just call this HTTP data manager, which is the instance of our data manager, and call its method set scope API options. Now, what this method does is that it allows us to set an API network interface for a given scope. If you remember when I was introducing OTSI, when I was talking about the data manager, I mentioned that the data manager operates on a scoped basis. What this means is that if you look at our HTTP CATS model, instead of taking it as an entire object, the data manager in OTSI allows you to scope this model and treat it either as an entire object or as its keys and values. In this instance, when I'm setting the scope API options, if you look at the scope already from IntelliSense, you can see for my scope, I have the option of model root, of which model root refers to the entire model or the entire or the complete object in our instance, which cuts model, or we can have the IMG key as our scope, which means whatever network interface I'll set right here will be for data mutations that are for the data that is held in the key IMG. But in our case, we want our network interface to be for the whole object or the whole model. So we'll choose our scope as model root. And then finally, we'll now specify our network interface, of which for that we'll first provide model root again, as we provide an object, and then we have model root as its first key. And then for that, we'll have model root will have an object, and then right there we provide network interface as now the other key. And then now right here is where we'll define our network interface. Now to completely illustrate the scoping, let me just add another property right here. Property. We'll have it as data type will be a number, and we can call this num cards or number of cards. Let's assume there was this was a piece of data that we needed. So our model has changed. We now have IMG takes the data of type string. We have numcards takes the data of type number. Now, when we are setting our scope DPI options, you'll notice that my scope, get rid of model root, numcards has been included in the scope, and Oats of the data manager in Oats actually infers scope even for nested objects. So if I were to add another property here, so what is actually an object is, and we have a cut age, and that is a number, and then we call this property, we call it extra. Our model has changed, it has been updated to this type. Now our scope also automatically updates, and you'll notice now we have extra, and then you have extra dot cut age, which infers the cut age key inside the extra, the object that is provided by extra. And this will go as deep as your nested objects are. And also, if this was an array, let's turn this into an array, OT will also be able to pick that up. And so you will notice that now our extra is inferred by extra dot array to mean there's an array there, and then you have cut age, and also have this special scope called self type, which basically will infer to the entire array. There is a will refer to the object, specific object, this right here, this cut age number, this right here, self type will infer to that, but extra dot array dot cut age will refer to number. Now we will look at scoping. We'll understand scoping more as we look into the data managing more advanced scenarios. But basically what you need to know for now is that data manager works by scoping, which allows you to fine-grain data mutations. You can operate on your entire model, you can operate on pieces of your model that are identified by the scope. And the scope is simply a dot path, simply just a path to a specific data value inside your model. So we can actually need this. So you can get rid of them, or you can just leave them. It's not going to affect anything. I'll just leave them. or maybe if you want to infer to them later and play around with them. For our case, it is the model root. We'll specify the model root and then set the model root as an object. Inside that object, your network interface, and now we have to specify our network interface. Now, as far as the network interface is concerned, now for the model root, or just network interfaces in general, there are three methods that you need to provide in your network interface. You need to implement rather. This is get request body, on data load post process, and on data load error. Now, get request body is where when the data manager is running the network operation, as far as a specific data mutation is concerned, this is where it gets the parameters for the request. Not just the request body, it will get the request body, the request headers, the request method, response type, and all these other values that usually providers, let me call them just parameters in general, that will make your API request successful. On data load post process is called after the network request has been completed and you've received a response. This allows you to post-process the response so that you convert it to, if there is need, you can convert it to the appropriate model that your web app uses as far as your data manager is concerned, your specific data manager instance is concerned. And then on data load error is called when there was an error with the network request, and it allows you to package a response that you can show to the user in regards to the specific API error that you encountered or network error that you encountered. So let's first deal with get request body. We'll have a method. It runs a promise, so as async get request body, going to get the request address, updated model, mutation, the type of mutation that's taking place, complete old model that we had, and then now what we have to return for this is basically an object that will have the request method, response type, and any other parameters that we have. Because for instance, you can see if I wanted to put headers, there's the request headers key that I can use to pass in my headers. We have the request method. For our case now, we have request method, request address. If you want to override the address that you provided, because normally you'll find that there's already an address that you'll provide when you're about to invoke a network operation. But if you want to override that address, let's say for cache busting or any other purpose, you can also override it here. So I'll just look at what we need specifically for this tutorial. We'll need to provide the request method. For this, we're going to do a get and then response type. For response type, we're going to expect a blob. This specific API that we'll be using returns an image blob. And from that blob, we generate a URL of which that's what we provide here as the value of img. Now, after we are done implementing get request body, now the next method that you're going to implement is on data load post process. This one is a request address, response, new data, old data, mutation, month, data ID, and some extras. Now, once you get a response from our API, it's going to return a blob. But our model wants the image in form of a string, which we're going now to attach as basically the URL. In our image, we'll have an image element. We're going to attach that URL as its source, and then it will load the image that we have. Now for that, you're going to have to convert our response, the blob, into a URL. So we're going to use this method right here. So we're going to create URL blob, and put this in a constant. URL is equals to URL create object URL, and get this response. And finally, we'll want to put this URL inside our model, because remember this API options for model root. So we want to put this URL inside our model, specifically at the image key, inside the image key. Now to do that, you can manually try to install that and have, let's say, final data equals to an object, and I have final data image is equals to URL. Now this will work, but the problem with this is that when you're in real world applications, you normally don't have simple models. Models can easily get complex, and having to do this kind of object creation is tedious and can be error prone quite easily. And also, when you update your model, you have to update everything. Now, what you can do is you can use a data manager method which handles this for you automatically, and I'm going to use it, and I'm going to show you shortly. Now, because of context, I can't access this .http. I can't access our data manager instance. So what I'll do instead is that I'll just have a method here. We'll get data manager, we just simply returns the instance of our data manager. And now with that, what I'm going to do is, instead of doing this right here, I'll create an empty object first, final data, and then I'll use my data manager instance, which I'll get data manager because of I've explained because of context. And then we have this method called spawn partial shell model. What it does is that it allows you to specify a scope of your model that you want to insert data to. So in our case, that is the image scope. And then we provide the value, of which you can see automatically it infers this value should be a string, which will be your URL. Provide that URL. And then we give it a reference model. The reference model is the model where it will insert the value of this scope inside. And in our case, that will be final data. We want this to be inserted inside final data. And then you can provide a mapped, the mapped data ID, which I'm just going to use the mapped data ID that was passed here. And that's it. After this method runs, if you have to check your final data, you'll find that the value of final data image is the same as this URL. And you can do this for all your models. You just specify the scope, give it the value that is supposed to be inserted for that scope, give it the reference model, passing map data ID if the method that you're using has it, and the data manager will automatically build that object for you and insert the value in the right key. Now, with that done, finally we can return our post-processed data. Do that, we'll return an object, and you have the data property, of which you can see it expects a partial of our model, HTTP cats model. That will just pass final data, and then we'll just pass the response that you got. Now, they are complete. The final method that you're going to implement is on data load error. This one doesn't return a promise. Then request address, response, new data, old data, mutation as the parameters. For this, we just return our response as the response you got from the server. You're not going to try and repackage that response into what you want to show in our UI. Just leave it as is. Now, with that done, we've implemented our network interface, specified its scope. I've explained what scoping is. We've now provided the object that represents our network interface, and then implemented the three methods we need to be implemented for the network interface to work. Get request body will get just the parameters that you need for our request. Data load post process will allow us to post process the response. Data load error will allow us to repackage the network error that you've gotten. And remember, this network interface works in conjunction with the remote request utility to now fulfill network requests that allow the data manager to perform data mutations using the network or through the network. Now, we have completed setting up our data manager. And as far as our image right here is concerned, our data manager finally has a network interface. Now what's remaining is a view manager. They actually show the reactivity at the interface as the data manager handles mutations. Now, to do that, we will we'll come back to our constructor, and underneath setup data manager, we're going to add this method right here. We're going first of all to specify an instance of the HTTP card standard view manager. So when we come back right here, then this is for our view manager. Then this the HTTP cards view manager. We'll have that as null for now. Then finally, we call the method is that set up view manager. Now, this is the method that will actually set up our view manager, and we are going to implement that. Up view manager. Now, before we implement it, we'll just annotate its type. So I'll come back to that shortly. Let's first specify its. Let's start implementing this. So we'll create an instance. We had it as null in the constructor, but now inside this function, you're going to actually create the instance of our view manager. So I'll call this HTTP cards view manager with new standard view manager. Now there are two types of view managers in Oats. We have the standard view manager, which manages just standard views. These are basically views that manage a single data item or a single model. So all that means is you don't have recurring piece of data that you want to show within a list, as simple as that. If you want to use a list, we'll have that example in the movies main fragment. You're going to use the list view manager. So for the standard view manager, we're going to pass in an instance of the data manager, but you can see it's inferring its type as unknown. Now to correct this, we'll come back to our constructor where we specify we are initializing our, what are we specifying? We're setting up our HTTP cards view manager instance. Now we will annotate it using JS docs and specify its type to be the standard view manager of the standard view manager, and the first thing that it will expect is the model, and the model is a CATS model. And then for the next thing it will expect is a scope. Remember, scoping is a big thing for the data manager. The same thing as we attach view managers, we attach view managers to a scope. This view manager, now if you look at this diagram again, network interface doesn't operate globally, it operates at a scope. View manager also doesn't operate globally, it operates at a scope. This means you can have several network interfaces and you can also have several view managers to just give you that granular control over your data. Now, in our case, we want to have our view manager receive broadcasts for data mutations that are happening at the whole model level. And for that, the scope for that is model root. Because we don't want for image for the string, we don't receive broadcast for changes to this. We want to receive broadcast to changes to the whole model, which is model root. Now, having specified this, if we come back here to where we're getting our instance, now you can see that the expected data manager instance is for the HTTP CATS model, which is correct. And then we'll have our options inferred correctly. So our data manager instance is this the HTTP CATS data manager. And finally, we're going to pass in some options. And in these options, we'll now specify our scope. Previously, we specified our scope in JS docs so that IntelliSense helps us write code and understand what each method will do as far as our model is concerned and its scope. Now we're going to actually now provide the scope here that will be used internally. So we have that scope as model root. And then we will have an ID. Pass in an ID. And this ID as HTTP CATS view manager. This is basically the ID of the view managers in case you want to check whether you have the right one at some point. You can just do CATS view manager.id. Let's get that. And it will return to you this value or some random generated value if you didn't provide it. And then we're going to provide view options. So in this case, it's going to be an object. And that object is going to take several values. We're going to have parent node ID. Now that as CATS results. And then inflate content view node ID. Inflate content view node ID. We'll have that as new cut. Then we'll have value reflect root view on a new model. It's root view, new model, pass that as true. So let me explain what's happening here. Now, for the view options, we're going to pass our parent node ID, of which what the parent node ID is basically the ID of the container that this view manager will be managing. So when in our example right here, if I inspect our HTML, we only have up to our button. Now we're going to add another div, which will be where our cat images will be shown. And that div right now, and that div after we've added it and given it the ID, cat's results, is where this view manager will now be managing the view that is shown as it receives broadcast about data mutations from the data manager. Now, this next property right here, reinflate content view node ID, basically is now whatever will hold the content, because this is the container. And then we're going to have our image. Whatever will be holding our image element will now have this ID of new cut. Now, the reason for providing this is you have this directive right here, reinflate root view on new model. What it basically tells this view manager is, in case the data manager clears its model, and it's specific to the standard view manager only, as you will see later. In case the data manager is to flash the model that it has or delete the model that it has and load a new one, this view manager, when it receives that broadcast, should remove from the DOM the content or the node that is represented by this ID, new cut, of which now it's a child of its parent node ID. So it should remove the element with this node, and then it will reinflate it once it's done. Now we'll see this practically shortly. The last thing that we'll just provide to our constructor is the lifecycle options. And here we basically provide our lifecycle instance, and we get that using the method get lifecycle object. Now, because you're passing an instance of our lifecycle object, this also tells you the view manager is lifecycle aware, so you don't have to worry about receiving broadcasts when your fragment has been destroyed, because the view manager will be aware of that, the view manager, and it will stop receiving any broadcast and responding to them, and allow the cleanup and of the fragment basically. Now, with our instance setup, what we're going to do next is register our hooks. Now, the hooks are what will allow us to now respond. Hooks are what will now allow us to respond to the mutation broadcasts that come from the data manager when specific data mutation is being performed. Now, to set up our hooks, what we need to do is call the instance, get the instance of our view manager, which is that's view manager, and call the method register view data hooks. Now, we'll have two hooks. We'll have the root hooks and we'll have the component hooks. Now, for today, we'll only look at the root hooks. For the root hooks, we'll have two key hooks. We'll have the builder hooks and we'll have the pre-post root attach hooks. Let's start with the builder. The builder is basically where we provide the views of the view that the view manager will render once it receives a broadcast that a new data has been added to the model, or a new model has been attached, has been loaded by the data manager. And it also communicates back to us when that view has been attached or when it is about to be detached, because that specific model or data referenced by the scope is being removed. Now, as far as applying our view is concerned, we have the inflate root method, which we're going to implement. For this, for inflate root, sorry, I haven't read this correctly. It's supposed to start with root. Sorry, supposed to start with root. Okay, builder, and then you have inflate root. There you go. Now, Inflate root is when we'll provide the view as a HTML string that will be attached to the DOM inside the parent node ID by our view manager. And this method will receive data, the new data that has been loaded as a parameter. And you can see this is of the type HTTP cats model. Now, what you're going to do simply is to just return our rendered view, our templated view, which in this case is going to be put in the inflated view property. And for our case, because we use handlebars, you're going to get it from a handlebars template. You're going to template this from a handlebars template, and that will be inside views, new cut.hbs, new cut.hbs. And now when we call this JS function that handlebars will give us to actually template this view, we are going to pass in data. Now, that data will have the image property, which will actually provide the URL that you need for to actually show the image that you have retrieved from the HTTP cats API. Now, the other methods that you need to implement include on view attach, which takes in a model ID, data, view node. Now the view node that has now been attached, which will have this ID right here. And then mapped data ID. And then some extra arguments. Now, we have no use for this right now, so you won't implement anything inside there. But basically, whenever once your inflated view has been attached to the DOM with the view manager, this method will be called. And finally, we'll have a method on view detach. We'll take in the model ID, data, view node, or view node that you have inflated that is now about to be detached from the DOM, and then a complete callback, which comes in handy when you have to animate something. When you have to animate something, because sorry, that's right, marked and just have this as a complete callback. Now, this complete callback comes in handy when, let's say, you have to animate the removal from DOM, and then you want to tell the view manager once you're done. But it doesn't stop the broadcast and how fast they're happening. You'll have a complete look about on this later. But basically, for the builder, these are the methods that we need to implement. This one gets our view. This gets called once our view has been attached, and then this gets called when our view is about to be detached. And then finally, we have the pre-post root attach hooks, which is apply after the builder hooks. So what these hooks are for is that these hooks right here now receive broadcasts that allow you to make changes to your view in the context of the parent node. So in case you want to show a loading view, like this loading spinners or loading animation, or the network mutation has failed or the data mutation has failed and you want to show that error, this is the hook. This is the set of hooks that you use. because the view node that will be passed here in these hooks reference the parent node ID. For your builder, on view attach, on view detach, this view node is referencing now the content view node. But for the root attach hooks, this now reference the parent node. I'm going to do that practically. I'm going to have to implement the methods that are there. You have 4 methods. You have on mutate, on commit, on cancel, on error. On mutate is called when the data mutation is happening. The data manager has initiated the data mutation. So we are loading something from the network, or you're pushing something to the network, or is just something internal. And then on commit is called when the mutation is completed and that the new value, or basically the mutation itself, has finished, completed. That's when you get the on commit call. On cancel is when the mutation has been cancelled. There's either a network issue or it was something internal. On error is called when the mutation has failed and you want the user to have the option to immediately retry. And we'll look at the difference between an error and on cancel later. Either can be called depending on how you've specified your mutations to fail. If you want your mutations to fail with an immediate option to retry, on error is called. If you want your mutations to fail and fail completely, on cancel is called. Now, let's implement each. We're going to have on mutate. And this method will take in a model ID, mutation, new data, old data, parent node, then some extras. And then in our case, what we're going to do is we'll want to show a loading view. Now for that, we're going to just directly insert our view to the DOM. So you just go to the parent node, insert adjacent HTML, do this before end. And the view that you're going to insert, get it from our template. So just file views. You have this in a folder called loading UI. And I have that as loading UI.hbs. Loading underscore UI.hbs. And then this for loading UI, you just pass a witty message because you want to reuse it. Now move this fragment and pass a witty message, and that message will be just a meowment. Now, basically now whenever the data manager will be initiating a mutation, we'll be able to load our loading UI here directly. Now we'll implement the other methods that we have. We have on commit, then also take model ID, mutation, new data, old data, parent node, extras. So what we do with on commit is that now that we have our data loaded, we'll just remove our loading UI and we'll use the remove child method for our parent node. And basically, we'll just query the ID of our loading UI, which is hash loading UI. So I say remove child, we're going to use parent node query selector hash loading UI. And we'll also want to do this our mutation is cancelled. So we'll also implement on cancelled, love method ID, mutation, new data, old data, parent node. Also take the response that he had formatted through on data load error, and then some extras. I will do the same thing here. And then we finally implement on error, though we won't use it because all the data manipulations will be failing and failing completely. Mutation, data, fail, data, response, parent node. And then finally, the retry callback, and then some extras. So in case you have to ever use on error, you can just load up a UI in your parent node, and right here, the parent node, and then have a button, let's say a retry button, where now when the user clicks it, you can just call retry callback and pass in through, which will instruct the data manager. This will bubble back to the data manager, and it will instruct the data manager to retry the mutation again directly. But we won't need it for this example, so we're going to leave it like that. Now, the final thing that you're going to do is that now that you have our root hooks, there are also things called component hooks, but you won't need them for now. You just pass null. But basically, what the component hooks allow you to do is, to use an example, it allows you now to fine grain the responsiveness of your UI elements to the data mutations, in the sense that if, let's say, I might want to make changes to the numcats property, and I want to update a bit or a specific bit of my view node. When that happens, of which my view node is basically what holds my content for that now particular model, I can implement these same methods right here. I can implement on mutate, just provide the hooks, and then implement on mutate, on commit, on error, on cancel, and have that specific bit of the content node respond to those changes, instead of having the entire content node receive a broadcast for something that is finer grained to it. It's not affecting all the elements within it. It's affecting a specific element. That's what the component hooks allow you to do. But that's something that we'll look at later. For now, just post this as null. Now, with our view manager setup, we've got in its instance, we've registered our hooks. Final thing that you're going to do is now register it to the data manager. You're going to do this using the data manager instance, http data manager set view manager. And the first argument that you take is the scope. Remember, our view managers for the scope model root. So you need to tell our data manager the same thing. Finally, passing that instance, you can see now it has referenced the correct instance, which matches the instance that you have right here. So this dot http cards view manager, and then you have some init args which you don't need for our case, so we'll just pass that as now. So this will finally now provide the view manager that you've set up right here to the data manager, so that this structure that you have right here is finally complete. The network interface is in, the view manager is in. Now the data manager can use the network interface to perform network operations as far as the model is concerned and broadcast whatever it's doing to the view manager. Now, if I had multiple view managers, I can still use this method, provide the scope, even the same scope. I can have a different view manager managing a different bit of the view within the fragment for this model root still, and just attach it like this. All of them will receive the broadcast from the data manager. Now, this done, with this done, what you're going to do next is now you're going to finish up everything. And what you're going to do is, before we attach, because the next thing that you have that is logical to do is to now attach the click listener to this, event listener to this, so that when you click, we are able to trigger the data manager to tell it to load data from the server and have that displayed here with the view manager. But before we do that, we need to supply the view manager with the views that it needs, because if I'm to save this file right now, I'm going to have some errors, 2 errors actually, because this loading UI doesn't exist and this new cat HBS file doesn't exist. So we'll create those folders now. We'll have the new cat folder, and inside that folder, we'll have the new cat.hbs file. Now what I'll do is instead of us having to write this markup from the start, I'll just copy what I had right here. Just slowly and just shortly explain it. That should do it. So this is the markup for the content view that will be shown once a new cat has been loaded. So basically, we just have our div, and this is the ID that we provided. Remember here, when we provided the content view node ID, if it is a new cat, this is what it's referring to. Providing this will now allow the view manager to actually target this markup right here, remove it from the DOM, or attach it whenever it wants, whenever it needs to. And then in our markup, you can see that now we're using handlebars to its actual use. You can see our image source is provided by what we get as IMG, which you remember for our model. Our model had that property, which is basically the URL, which will provide you a source. And then you have this HTTP code and message that you can optionally pass. You can expand this model and pass that, and when you're rendering the view, because it's part of the model as far as our scope is concerned, that will also be rendered right there, but we will not use that for now. And then the other thing that we'll do is we have this parent node ID, cats results, that we need to provide in our markup. Remember, our markup ends at button for our fragment. So we need to add this. How we'll do that is we'll come here to HTTP cats fragment, to HTTP cats fragment. Here we had completed it. Just copy this. It's just a div. You have it right here. You can pause the video and just add it. It's just a div, just this one line right here, and that's fine. And then there's a bit of extra CSS that you need to pick up. You can get this directly from the code that I provided. You just copy here, it is for lesson 2. I'm going to paste it. Then now you can start from here. Lesson 2. So you can just copy directly from the GitHub repo. You just go to the http://css file, just copy that, whatever is in that whole file directly, to just save yourself some time. But this is just basically styling to just make sure the markup looks as we want it to look. There's nothing special here as far as Oats is concerned. And now finally, the view setup, we're going to implement this loading UI right here. So we'll add that folder. And add the file. And then just copy the code. Just take it directly from the repo. Link is in the description to just save you some time. And remember, when we were implementing our UI, we had this witty message property right here for our data. And we're using it here. You'll see that in action. Now, what's left for us to do? With all this done, is now to actually add an event listener to our button, the meow button. This button right here in our markup, this one right here. This is just above where we're going to our view manager, the parent node that our view manager will be managing. Now, to do that, within our fragment, we have an internal method that you can override called on UI bind. This method is basically called whenever the OT has attached the view that you provided here at initialize view. When this view is finally attached to the DOM, OT makes this call to your fragment on UI bind. And now right here, we can now bind our listeners and do whatever it is that you need to do now as far as our rendered view is concerned. So in our case, we'll just attach a listen on the meow button. So we'll just do document get element by ID. There are several ways you can do this. You can use document or get element by ID, or if you want to be specific, you call this get content node, which will return the parent node with this HTTP cat main fragment, this one right here. I'll show it in the markup. This one right here. It will return this node, and from there you can query any selector that you want and get that node directly from the DOM. But in our case, instead of having to do that, document to get element by ID does the same thing. So we'll just do that, document to get element by ID. And our ID for this button is get cut. Add event listener. This will be for a click. Then the function where we will handle that click. So what we will do first is, because you want to load a new cut image every other time you click on this button, if there's an image that was loaded and therefore we had a model in our data manager, we want to clear that first. So how we do that is the data manager has this method. So I'll do an if this that's data manager that has data. This method basically checks whether ask the data manager to check whether it has some data, and if it's true, it returns true, or if not, it returns a false. So if this the data manager has data, what we'll do is that we'll clear this data and we'll use the method cast data manager dot flush all data. So this will clear all the data that you have inside our data manager, and you can optionally pass an argument right here, but we'll not look into that today. So we've cleared any data that we had so that you can load a new cut image of the API call. And then finally, we're going to load a random cut. And to do that, we'll first get the HTTP code for that. And we'll just copy the code that does that. And we do that using, we get our status code using, remember, a random codes list, which is an array of all the numbers. We're going to use the random number character generator utility, which is an internal utility that comes with Oats that allows you to just generate random numbers, give it a range, and it will generate a random number within that range. For us, our range will be from index 0 to the length of a random codes list array. It will not include the length. And then here, once we have our status code, we are going to now load data. And to do this, we're going to call the load data method, the data manager. And this will be done through this, the cuts data manager, the load data. Now, remember that your manager works on a scope basis. So you have to tell it for which scope you want to load data. In our case, we have multiple scopes. We have model root, extra, image. As far as our model is concerned, these scopes are specific to the model that you have. But in our case, we want to load data from model root because you want to load a new cut image and put it in the model. And our network interface that will be used for this operation was also specified for the model root scope. So you want to use model root as our scope, and then pass the null for the scope info, and then our send data options will just pass an empty object. Passing it as null for now brings an error, but that will be fixed. We'll just pass an empty object for now, and then pass null for that value, and then we have the value of an override load new address. This is basically the address that should be used to make the network call to load the data for this scope. This, when we're making this load data call, this is the address that you should use. So for that address, the API that you're using is the HTTP cuts API. Let me just show you how its address looks like, and then we'll talk about a small quirk that you have. Now, the address looks like this. Now, we'll use this for now, but then you'll notice you'll encounter an error, which I'll explain why we have that error and then how we can bypass it using the proxy server that usually comes with a Oats project setup. Now, this load data method returns a promise. which we can catch in case of errors, or use the .10 to do any form of processing that you want to do after the data has been loaded. Now, in our case, we'll just implement catch. So we don't get some issues. And then with that, when we catch, usually what C passes in an error is associated with the failed data mutation, why the data mutation has failed, and then you can be able to handle that right there. It's just good practice to catch it. Now with that done, our fragment should be fully wired up. And what you should see is, now when you click on Neo, you should have something loading. But if you check our console, load, check our console, you have that loading. We had that loading screen that came, but then our GET request failed. The reason why it failed, it's because of a cross-origin request blocked by CORS policy. No access control allow origin header is present. Now, this is not a problem with Oats. This is just a problem with the API that you're using. We can't use it directly on the browser because it doesn't provide this header that will tell the browser it's okay to make a cross-origin request from our origin to this different origin right here, the HTTP CAT API, and the browser will just simply block it. And so we'll have our loading UI right here, but nothing is happening. And as far as the loading UI is concerned, just for illustration, as you want to deal with that error, remember we are providing that right here. We had our root attach hooks, pre-post root attach hooks, which were allowing us to add to intercept broadcasts about data mutation happening and make view changes in the context of our parent node. And right here is where we are inserting our loading view. So if I were to comment these bits out, you will notice that now I'm not getting the loading view. The network request is happening, but I'm not getting the loading view. Nothing. But if I were to comment it at onMutate, you'll notice that when I make the request, I now get the loading view. But the loading view doesn't disappear after we get an error. And that's because here at onCancel, the request is cancelled if the mutation fails, it fails and fails completely. So onCancel is broadcasted to our view manager. We are not doing anything here. So if I'm to comment this, to uncomment this, save that, now our loading view should be disappearing the moment our request fails, and this is broadcasted. So basically that's how things are happening. Now, to deal with our CORS issue that you're having right here, we'll come to our proxy. Into a proxy server. And our proxy server now allows us to use, because we can't make this, we can't make that call to this URL right here within the browser. And it's not our fault completely, it's just an API design issue from the other end that you have no control over. We'll now instead proxy this request through our own dev server. So how we'll do that is, this is a library called managed HTTP. Managed HTTP proxy. I'm just opening it right here. Yes, is the package manage HTTP proxy. So what it allows us to do is just use the node HTTP party library, the HTTP proxy library from HTTP party to actually proxy network requests through our dev server. Now to install that, we'll just do it quickly. If you're using the code from GitHub, you don't have to install it. But if you're using from the code, if you're coming from the code alone that we've done previously, we're just going to do npii, have it as the development dependency managed HTTP proxy. Now with that library installed, what you're going to do is for our proxy server, we're going to update its code to look like this. So we're going to first require that library. Just have first proxy require manage HTTP proxy. This is a library that I wrote when I was developing for VAT solutions because I encountered similar issues quite often. So just proxying the request, and also it allowed me to develop the backend and front end separately, and just instead of adding that header to my own server, to just have my server block cross origin requests from browsers, and then personally when I'm working with the front end, just proxy to my own server. Now with this installed, what you're going to do is this imported rather, what you're going to do is we're going to create our server that will now target the HTTP cat API, and we'll set it right before this directive right here. So what you're going to do is to use that library quickly. I'm going to call my cat server customer HTTP proxy dot create proxy server. There are no options. We're going to pass in the target. Now we'll pass this. This will be the target now instead, because you want to proxy right there, and then we'll have this change origin property set to true so that you can make HTTPS requests from a HTTP server. And then what you're going to do next is, once you have gotten a cat server ID, we're just going to now specify our internal path that we'll now use. Instead of what we had here, we'll now use our own, which will now proxy our own route, which will come to our dev server, and then that will be proxy to the HTTP cat server. This will give us the response. This proxy will now return that response to our browser. So for that, the route that we'll use is this. Don't worry about it. This is a bit of Express. It's a bit outside the context of what you're doing, but we'll just specify that. And then just copy this right here. You can get it directly from the repo. This is basically set up our and change this to cat server ID. Yeah, and then have this set up like this. So what we'll basically do is, for us, instead of making the call that we had right here, we're going to update this to this new route that will go through our dev server, and we won't have a CORS issue. That route will be /API /cat at slash. Now we provide the status code that we have. Status code. Now with that, the request, instead of going through here, HTTP cuts directly, it will go through our dev server. Our dev server will now proxy it right here to the actual API and return the response. And now we should have no CORS issues. So we'll just clear this and then restart our Webpack dev server. And then now finally, it will hit me out. Oh, let me reload the page so that you get the new one. Yeah, if you hit me out, finally it loads. The API is now working. Now, if I'm to hit Meow again, you can see the loading view come, new cut view is loaded. And you have everything working fine. So if you wanted to inflate a different view, I could have changed this to even a string. Some view. See, instead, this is the view that will be rendered. Then you'd have that error because it couldn't detach it, because it didn't. This doesn't have that ID. So you can actually bypass that by just giving it an ID. New use backticks. ID. Just a new cut. And that. There we go. Now working fine. So you actually have a good illustration of where new cut comes in. Now just revert to where we were before. And that's it. You can now get random cut images with a loading view. So that's it for this video. We've been able to add reactivity and data management to our web app that we built previously. We did that using the view manager, data manager, and network interface. Because of time, we're going to do the movies fragment in the next one, and that should be easier to just follow along. Instead of using the standard view manager, we'll just use this list view manager, and you'll notice nothing will be different as far as implementation is concerned. Now, I'll see you then. Leave a like and subscribe. Check out the source code. We also have a documentation page that we just launched today using GitHub pages. So you can find a bit of documentation of the methods that you're seeing right here in Oats. And I'll see you then. Cheers.